Hello dear students, welcome to Vision Pharmacy. In our today's video, we are going to see some basic concepts which are related to chemistry. So, before we start with our today's video, please do like, share, subscribe and press the bell icon for getting updates on upcoming videos. Let's begin students. The first term is atom. So students, atom is the smallest particle which may or may not exist free but takes part in chemical reaction. Okay, atom word means not to be cut, okay, which cannot be cut. Example H, Na, O, etc. These all are the atoms. Now the second term is matter. So students, matter is anything that occupies space, has mass and which offers resistance and can be perceived or by directly our senses. Okay, then moving to next one, element. So element is the purest form of matter and it is made up of only one type of atom. These substances cannot be broken down into simpler substance by any means. Example, carbon, iron, copper, oxygen, etc. Then the next term is compound. So students, compound is a substance which is made up of two or more elements combined together in a fixed ratio by their weight. Example, carbon dioxide. Then moving to the next term, that is mixture. So mixture is a substance which is made up of two or more substances in any ratio. Here the ratio is not confirmed or it is not fixed. Okay, so that is called as mixture. Now moving to next slide. Here the term is homogeneous mixture. The mixture which has uniform composition throughout is called as homogeneous mixture, whereas the mixture which do not have uniform composition throughout is called as heterogeneous mixture. Okay, then change in a substance from one state to another state without any chemical change is referred as physical change. Example is conversion of water into ice or vice versa. Okay, then in a chemical change, the substances that are present initially, that is the reactants, disappear and one or several new substances, that is the products, are formed or appear as the reaction proceeds. The properties of product is different from those of the reactant. So this is difference between physical and chemical change. Here there is no any chemical change, whereas here there is a chemical change and the reactants disappear, resulting into formation of the product, okay, which also differ in their properties. Now moving to the next slide. So next definition is of precision. Precision can be defined as closeness of outcomes of different measurements taken for the same quantity, whereas accuracy, it is agreement of experimental value to the true value, or accuracy is closeness of a single measurement to its true value. Getting? Now moving to the next one. So next definition is of atomic mass. So students, atomic mass can be defined as the mass of a single atom which is measured in atomic mass unit or unified mass. Okay, then the next is molar mass. So students, molar mass is the sum of atomic masses of the elements present in a molecule. It is obtained by multiplying the atomic mass of each element by the number of atoms and adding them together. Molecular masses when expressed in grams is known as gram molecular mass. Now moving to the next definition of gram atomic mass. So students, the mass of 1 mole of atom when expressed in gram is called as gram atomic mass. Now moving to the next term, that is empirical formula. An empirical formula represents the simplest ratio of the number of atoms of different elements present in one molecule of a compound. And molecular formula shows the exact number of different types of atoms that are present in a molecule of a compound. Then moving to next one, that is molality. It is expressed as m, that is small m. It is defined as number of moles of solute present in 1 kg of solvent, and it is given as m is equal to number of moles of solute upon mass of solvent in kg into 100. Whereas the next is molarity, that is capital M. It is defined as number of moles of solute present in 1 liter of solution. So students, there is only difference of kg and liter, and it is expressed as capital M is equal to number of moles of solute upon volume of solution in liter into 100. Then the next is normality, that is N. So it is number of gram equivalent of solute present in 1 liter of solution. Okay. Then moving to further definitions. The next one is fundamental unit. This unit can neither be derived from one another nor be further resolved into any other units. Example, time, mass, length, etc. Then comes derived units. So these units are the function of more than one fundamental unit. Example, density, area, volume, etc. Then is properties of matter like mass, length, time, temperature, which can be quantified and expressed in numerals with suitable unit is called as physical quantities, whereas the physical quantities which are derived with the help of two or more physical quantities are called as derived physical quantities. Example, density is derived physical quantity from mass and volume. You know density is equal to mass upon volume, right? So it is derived from mass upon volume and is known as derived physical quantities. Now moving to next one. So this is the term extensive properties. The physical quantities which depends on the size of the sample like mass, weight, volume, pressure, etc. is called as extensive properties. Whereas the physical quantities which do not depend on the size of the sample like temperature, density, refractive index, surface tension, right, viscosity, these are called as intensive properties. So I hope students these terms are now clear to you. Thank you very much for watching till end.